All right, welcome back everybody to another episode of Tech Transfer Insights. We're going to start a new chat with Gemini this week because I managed to screw up the question that I asked it previously. So we're going to say, please pick three random items. This list, and then give it the list of the R1 research universities. So let's see what it comes up with. UCLA, Baylor, and Brandeis. Okay, we already did Brandeis, so we're going to ask it to please pick a different third item. I avoided picking UCLA again. All right, University of Florida. So we're gonna do UCLA, Baylor, and University of Florida. All right, let's go find something from UCLA, which I happen to be going to visit here in a week or two, so that'll be interesting. All right, so finding one at UCLA was actually relatively easy. Apparently, they list them in chronological order, and this one happened to come out yesterday. So that goes to show that on a daily basis, some of these universities are posting additional things that could be potentially game changing in terms of usable technologies. One of the things that I haven't really talked about yet is the idea of a platform technology. So, a lot of times in material science, especially, there are technologies that can be used in more than one application. In this case, it's talking about, we'll say, a tactilely responsive material. So basically, I had not heard of these, but Joule heating electrodes or phase change materials, those are kind of, at least the phase change materials is kind of a buzzword in material science worlds. But soft actuators can be used in everything from robotics to, in this case, they talk about using it in clothing. So, in terms of where this can be useful, there's a pretty clear cut problem this is solving about related to the strain of these dual heating electrodes. But also they talk about using it in braille, robots, deformable apparel. So theoretically, you can change um, the stiffness or shape of specific kinds of clothing. But then also in surgery and medical training. So ultimately, this one has a lot of different um, use cases, as is the case with a lot of uh, material science technologies. So the goal with this would be to try to understand what's its killer app, right? What is the thing that is most useful? What is the thing this is most useful for? What is the best problem it is trying to solve? Uh, but there could be lots of them. So, the challenge there is you could build an entire company with all different sorts of implications around this thing, potentially, but also you have to find which thing is the first thing you're going to tackle. In my experience, a lot of material science uh, technologies have that sort of finding the killer app problem, which, it's a good problem to have, I would say. So, if you're interested in learning more about this kind of tactile responsive material, Mr. Traitler seems like it would be the person to contact, and they got some of the professors of material science at UCLA. So, the next one, if I remember correctly, is Baylor. All right, so we're going to do a little bit of cheating with Baylor because I spent a decent amount of time trying to find the list of technologies for the overall university. And despite the fact that somewhere on a vice provost webpage for research that said that there was a list of like summaries of technologies available, I couldn't find where that list was. So not sure if it exists. I'm not sure if, the website was just old and not updated. But in any case, there is a caveat that Baylor has a very famous College of Medicine. So we're going to go with the medical school that happens to have its own list of available technologies. So in this case, rather than the full university, I just looked at the available technologies from Baylor's medical school. And one of the things that I find interesting, especially a lot of the times with medical schools, is they have very specific medical devices that help facilitate things like surgeries. And I kind of equate it to something like a kitchen um, tool, or what do they call those? Utensil, or something like that, where they have in the kitchen you can find tools to help with almost any cooking process you could possibly want. But in this case, it's you can find tools that will help facilitate almost any surgical or medical procedure you could possibly want. So in this case in particular, uh, the Baylor College of Medicine has this thing called Bullseye, which is a scissor-like needle head holder for fluoroscopy guided procedures. So there's a couple of interesting stats down here that I thought were kind of cool. Um, so there were something like 100,000 lumbar punctures, and half of them were done with this fluoroscopy guidance process. And also a bunch of other different kinds of procedures that use what I'm assuming is fluoroscopy, which is also why I'm assuming a radiologist would do this because the imaging aspect of this would be a useful, you know, go to rather than some sort of actual surgeon. Though I guess there are surgeons that also use fluoroscopy. I'm not even entirely sure what fluoroscopy is, to be completely honest, but obviously it's used in tens of thousands of procedures every day or year, I guess I should say. The so I guess these very specifically designed scissor look like a surgical instrument, right? Scissor holder, needle holders is a useful tool for fluoroscopy driven surgeries. Um, so, it has the different benefits of enhanced accuracy and precision and radiation reduction, so you don't have to continue to image things. But basically, very simple design tool. Probably, I mean, this looks like a model, a very nicely made model. So my assumption is that it's, relatively easy to manufacture these things. I'm guessing there's a patent that I didn't actually look at. There's no patent. Huh, interesting. So that might be a interesting case here because, I could see somebody like Stryker or one of the major medical device manufacturers, taking this and just saying, well, I'm going to do it myself rather than licensing this from Baylor. But, you know, general idea of the medical device, especially surgery device industry, is there's a specialized tool for almost everything. And this is a good case study in one that could be useful for fluoroscopy procedures. So I think the final one we have this week is University of Florida. So let's go take a look at that. All right, so I think I found an interesting one from the University of Florida. And I gotta say, this process was a lot easier than trying to find one for the overall university, Baylor, or Baylor University, I think is what their actual title is. Uh, it was, it's as simple as looking up University of Florida technology transfer, and literally the first link takes you to a web page that then has a search technologies link at the top of it. So a lot easier, very simple to find, and had a lot of interesting ideas. And this is the one that I thought would be most interesting to discuss here. So basically, this technology is a novel type of biomaterial that can both absorb free radicals, which I think in biology are just a terrible thing in general from my very limited understanding of the subject, but also that uh, allows oxygen to consistently be released to the wound or to out of the material over the course of weeks, and they made this into a wound dressing. So, the thing that they mentioned down here is that how a use case of diabetic foot ulcers, which, the numbers with diabetes and even diabetic foot ulcers is absolutely insane, right? They have, The prevalence has quadrupled in 30 years, which is not a great thing for the overall health of humanity. So like 1 in 11 people, so like what's that like something around 8 billion people, or not 8 billion, sorry. What would that be? Probably more like, not quite a billion, but 750 million people, and then 15% of them have diabetic foot ulcers, which just are extraordinarily hard to heal. So that's, hundreds of millions of people that suffer from this thing. And if this works to solve that, then that could be an extraordinarily lucrative market. That being said, from what I can tell of the way they describe this thing, it basically has been proven in a lab, right? So that there is a way of showing that, it scavenges free radicals and provides oxygenation. I believe that they tested that in the lab. What it doesn't say anything about is what impact, if any, this actually has on real wound healing. So, use case makes sense, very clear benefit if it does work. But there still needs to be some de-risking to show that it actually does work. And there's plenty of resources to go about doing that, especially with medical things where it's a very clear-cut, discernible test. And there are people who specialize in running medical trials. Obviously, I don't think this would be as complicated as something like a drug trial, but it would be a necessary step, I think, before you could get any sort of uh, investment interest in this technology or company based around it. But that's what de-risking is for, right? And there's ways you can go about doing that and getting the resources to go do that. That's part of what I want to talk about in a different series of videos at some point where we go through the process of uh, what the steps are to do things like de-risking and increasing the value of some of these technologies. But for right now, with this one specifically, I do want to point out that while it looks like it works in a lab, it has yet to be tested on people, as far as I can tell from this. But overall, very clear-cut market. I mean, if it does solve the actual problem, huge market, right? Hundreds of millions of people, and a growing problem. I don't think the prevalence of diabetes is going to go down, unless maybe some of these what do you call it, fat destroying like Wegovy and Ozempic and all that actually have an impact on diabetes, which I'm not entirely sure that they will. But I don't see diabetes going down at any point in the near future. But for now, that is, I think, the third one for the week. And I will, I'd like to point out that, the if you think any of these are interesting, just, hadn't thought of that as an idea, have some sort of cross correlation with some other idea that you're aware of from some other place or anything like that, please feel free to leave a comment down below. Um, but also, I will put links for each of these in the description section. So if you want to find the individual technologies that I talked about today, you'll be able to find the links there. I still haven't come up with some sort of pithy outro for this, but maybe as I do more of them, I'll come up with something that's more formalized than me talking off the cuff like I seem to do so often. But thank you all for listening. I hope this gave you some insight into some of the really cool technologies that our scientists are continuing to invent on literally a daily basis. And I'll check in with all you all next week. Thanks.